Alright, let's test and see if this is up, and things are looking good. Alright, cool. Let me go in and just double check and make sure things are good. Yeah. Okay. I'll do an introduction to myself in just a moment. Well, I guess you guys actually can't even see me, so let me add a camera capture real quick. Okay, great. All right, you guys should be able to see me. There should be a little camera capture thing on there now. All right, so yeah, my name is Ben Nelson, and I do most of the teaching for the full-time and part-time class that we have going on right now. I'm also the one who's designed most of the curriculum, and anyway, yeah, so if you guys come and do our part-time, full-time, or 6-month-long classes, then I'll be the one that you're seeing, yeah, for a lot of class. So. Today we're diving into some more advanced JavaScript concepts, specifically callback functions, what those are, how to write them, how they fit into the larger ecosystem. And then we'll see how time goes, and maybe we'll jump into some other things. But yeah, so the stuff that we're going to cover today, this is stuff that is actually expected of our students to know and have down before day one of class even begins. So essentially, a lot of the stuff that you guys have covered over the course of the last 2 months or so, I guess, is that these are things that, let's see. So these are things that, sorry, I got distracted by a notification that popped up. Yeah, so these are the types of things that we would expect our students to have down cold by day one. So anyway, it's a whirlwind, and we start at a fast pace, but our students are doing really well with all the stuff that we're covering. So we do data structures and algorithms, common types of things that you would see in interview questions, for companies like Facebook or Google or Amazon. And we go into full stack JavaScript web development. We cover React and Redux and a bunch of modern tools for building out client-side web applications, and then we cover how to build out servers and databases and how all that stuff fits together. But yeah, a lot of fun stuff, a lot of material that we cover, and anyway, it's a lot of fun. So, also wanted to announce that our decisions for, at least for the 6-month-long university class, that will, I guess as far as interviews, like for the next round of interviews, those will be going out within the next couple of hours. We've had a lot of interest. There's been a lot of people that have applied. So anyway, if you didn't make the cutoff, don't feel bad. It's we just had a few number of seats and a lot of applicants. Yeah. So thousands of applications, and we're starting small for this first round. So so don't feel bad if you didn't get in. If you didn't get in, we'd still love to have you in maybe our 3-month classes or in future university classes that we do. So again, so from now on, I'm going to refer to the university classes like our 6-month class. So in the future, we'll be kicking off more of our 6-month classes, and as we scale up and get more instructors, we will be creating more opportunities there as well. So, so look out for that. We'll be announcing more information on that coming up soon. But anyway, we've had some really sharp people come in and advise us and help us to adapt a pretty cool curriculum. We are working with a lot of other companies to ensure that the materials that we're teaching and everything are being designed from the perspective of what the employers want our students to know. And so we're going to be going a lot deeper into computer architecture and lower level compiled languages, things like that. Anyway, so we're hard at work getting that all ready right now. So that should be good, and we look to the eventual goal is to be able to give everyone an opportunity to receive that kind of education, if they want it. So, all right. let's dive in and do some JavaScript. Oops, I did the wrong one. 1 second. Okay, display, video capture, go to that. Okay. Right, let me, oh shoot. When I deleted it and re-added it, it's all zoomed in. Can you pop up the open stream and take a look at it, Austin?
Yeah.
I guess I got it. Shoot. Okay. Sorry, guys. 1 second. I figure out how to zoom this out. Well, sorry, guys. Give me just a second.
Instead of doing display, do
All right, there we go. Sorry about that. And as you see me dragging everything around. Okay, great. All right, so callback functions. So in JavaScript, functions are pretty flexible. They're flexible with how we use them. And so there's a pretty cool thing that we can do. It's called it's the idea of a callback function. Essentially, what that means is that we can pass functions from one function into another function. We can pass them around just like we do, numbers or strings or arrays or objects. Functions can be passed around and passed into other functions, and so it's pretty cool, and it leads itself to some very interesting design patterns. So let's create a couple functions here, and let's play around with the idea. So let's do function say hi. So this is something that you're used to here. Let's just I'm just going to write out a simple function. Oops, what happened? I did Command S. All right, then let's invoke the function. So let me pop open the console so we can see the message that will print out. We run that, and we see that hi is printed. I'm going to zoom in a little bit more so we can see that a little bit better. Okay, so again, we have a function keyword, and then we specify the name of the function. This is a named function, and then inside of it, we don't return anything. We're not passing in any arguments, and then we just say console.log hi. Okay, so something that we can do is within this say hi method, what we can do is we can pass in a function. And so what that looks like, this is generally the way the callback functions are used, is that we can we write it in line like this. We write the function directly in between the closing parenthesis and the opening parenthesis. And so this right here is it's just an anonymous function. So again, an anonymous function means it doesn't have a name on it. So this right here is a named function, JavaScript function declaration. So a named function declaration, those are the keywords for this. This right here will be an anonymous function, so there's no name to it. But yeah, we just define it in line like this, and then this function will be passed in as an argument into this function. So we can specify a parameter to be able to reference that, and we can use the name, so CB is traditionally used in so like documentation on the internet, you'll see them use like CB whenever you see example code that's talking about callback functions. So CB for callback. And then what it does is it allows us to it gives us the function. So we can access this function that we defined right here up inside of here, and then we can invoke it. So right now it's not doing anything, but if I just put a little, oops, that's force of habit. Okay, so if I just put in hello like this in here, and then I hit run, we see hello is printed out. So the order of execution, what's happening here is that we are referencing this function that's declared up here, and then we're calling it. That's what the opening parenthesis means. When we specify the name of a function and put an open parenthesis after it, that is calling it. So we're saying, grab that function that exists in memory and invoke it. So we're going to invoke it, and we're going to pass in this anonymous function right here. So an anonymous function then gets passed in, and that's what CB is. CB, the parameter, references this function that we're passing in. So we pass in that function, and then we call it right here. It's almost it's exactly the same as if we said var CB is equal to, and then we took this function and stuck it right there. So that's essentially what's happening. CB is a variable that we are using to reference the anonymous function that is being written out right here. So again, this is the code pattern. In a moment, we'll walk through kind of some useful things that we can do with this type of a pattern. But yeah, essentially, it's all it is at its most basic level is just it's passing a function into another function as an argument, and then. So like if this right here is function 1 and this is function 2, we can pass function 1 into function 2, and then inside of function 2 we can call it. We can do whatever we want to it. We can manipulate it and do different things. So so we'll see hello is printed out 3 times. So functions again are pretty cool in JavaScript because we can put them inside of arrays, we can put them on objects. We can pass them into functions. We can return them from functions, and that's something that will that usually leads into the idea of closure. And so here I'm returning an anonymous function, and but I don't want to go too deep into that right now. There's kind of a little, I guess I'm going inch deep, mile wide, just kind of touching on a bunch of different higher level function concepts. So that would also be called a higher order function, a function that returns another function. All right, so now let's do something actually useful with this. This is kind of a contrived example, and I know that sometimes contrived examples make it a little more difficult to understand. So let's create a function that, let's see, all it does is it, all right, let's create a function that, well, I didn't want to go too deep there. Sorry, I was thinking of something else. Let's a function called sum. We're just going to call it sum. So this function, I'm sorry, that's a ES6 thing. We're going to go function sum, and then we're going to give it an array of numbers. So it's going to get an array of numbers, and then it's going to take in a callback function. So what this function is going to do is it's going to take this array of numbers, and then it is going to we're going to compute the sum of all of the numbers that are in the array. And so, well, all right. So with this lesson today, I'm going to go a little fast on some stuff. This is our final lesson, and so you can always come back and rewatch the video. But I am going to kind of do a little bit of an introduction and touch on a lot of different topics. And anyway, hopefully this is of value to you. All right. So what we're going to do is we're going to say that the sum that we're going to compute is going to be numbers dot reduce. Okay. So reduce is a built-in method for all arrays in JavaScript, and then what it does is it allows us to take an accumulator and then a value, and it allows us to take the contents of an array and reduce them down into a single value. And so what we can do is take in our accumulator and our value like this, and then we're getting kind of meta here, and then we can pass in a callback function. So we have a function that we're passing to this reduce method, and then what this reduce method is going to do is it's going to take our numbers that are going to be in our array, and let me put a comment up here so we can have a visual. We'll say we have 1, 2, 3 inside of our array, and so after we sum these together, we should expect to get 6 back. So what reduce is going to do is we call this on this array. It's going to pass in, and anyway, we're going to be able to reduce the entire array down to a single value. So what we're going to do is we're just going to go return accumulator plus value like that. And so then this is actually going to be the sum. So I'm just going to return that. This entire expression right here will evaluate into a sum. And I'll walk over this in you know, a little slower in just a moment. But it's kind of like I'm getting the code down, and then we're going to walk through it and break it down line by line. So right here we have the sum. Let's pass in 1, 2, 3. I'm going to log out the results so we can see it in the console. I'm going to clear it, run, and then we see 6 is printed out. So yeah, so it's so reduce is one of those. And this ties in with the idea of functional programming in JavaScript. This idea of having methods that we can chain off of our arrays and off of our different data structures. When I say data structure, that refers to like arrays or objects, strings. Those can all be considered data structures, or way that we have data or information in memory. So numbers.reduce is going to, we're going to pass in this callback function. We give them a function, and then the reduce code behind the scenes is going to use this function. It's going to call it a couple times, and it's going to pass in this accumulator, and it's going to pass in this value. I'm going to console.log the accumulator and the value while we're going through, so that way you can see what it looks like while it's running. But we see it passes in 1 and 2, and then 3 and 3, and then 6 is what prints out at the bottom. So the accumulator is initially the first item in the array, and then value will be 2. So we return 1 plus 2, and then where this callback function is being used behind the scenes, that 3 gets returned, and then it's going to pass that 3 in as the next accumulator and then give us the next item in the array, which is also a 3. So we'll have 3 and 3 come in. So we log out 3 and 3, and then we return 3 plus 3. And so then this entire reduce call with numbers, that's going to return, and this will evaluate to the number 6, which we then return from the sum function, and then that gets returned here, and then this expression right here will evaluate to the number 6. So it kind of simplifies down. Okay. All right. Okay. Let me know if there's still sizing issues, and then let me just check. Something real quick. Okay, cool. All right. All right, so let me know if you have any questions. Okay, so all right, so this right here, we're using a, yeah, so to use reduce, you have to use a callback function. Numbers CB, so numbers, and we're not using this CB right now. We're not using the CB yet, but the CB often takes the place of a return statement. So now here I'm going to change this example a little bit more. So right here I'm invoking sum, I am passing in the array, and then now I'm going to pass in a function, and then this is going to give us the result. And down in here, I console.log the result. Okay. So now what we're going to do here is we have our result. So this right here is all going to compute down to the number 6, and then I'm going to take the result and I'm going to pass it into the callback function. So, so if we come back and then run this again, we'll see that 6 prints out. Let me nuke this console.log, and then we just get 6 that prints out. So, so sum. So this right here is a very common type of a pattern, where you will have a function, you'll invoke it, you'll pass in some type of a collection, whether it's an array or an object, and then you'll have a callback function that's going to handle the result. So sum is going to sum together all the numbers that are in the array, and then it's going to call our callback function and then give us the result. And then we can print it out or do whatever we want with it. So this right here is a very common pattern. So sum, this function, it goes in, it uses reduce, and it computes the sum. If the reduce thing is still is confusing, don't worry about it. But essentially, this right here, this expression is going to compute the number 6, assign it to the variable result, and then we pass result into callback, and then callback again is a reference to this function, and so we pass in result like that into that function. So it's a little bit of like this little twistiness, like it's a little bit of a kind of some spaghetti that we have going on here. But once you wrap your mind around it, this is anyway, it's a very, very common pattern. It's used all the time. So if you've played around with jQuery uses this all the time. With Node and Express on the back end, with JavaScript server development, you're using callback functions all the time. Yeah, it's when you're adding event listeners, things like that. Often these are used with asynchronous code. But anyway, I know I'm dropping a lot of nouns right now that you may have never heard of before. Just be a sponge, absorb what you can. There's just the stuff that you'll have in your homework will be a little more simple than this. But all right. So well, you can actually do kind of the same type of thing in Python. So this is, but anyway, different approach. But let's go in and look at, let's do a little more of a simple example. Let's say that all we wanted to do is to create a function that's always going to give us the last item of the array. So this one, it'll be a 3. So if we're going to do or if we did 5, like a 5 was the last item, then we're going to do a 5. So, all right, let's do, all right, so we'll call this last. So function last. All right, so then last, what it's going to do is it's going to take in a collection, or it's going to take in we'll just say, I'll say collection because it's generic. It doesn't, it could be an array of anything. It could be numbers, it could be strings, it could be an array of objects, it could be an array of functions. It doesn't matter. So we're just going to get this collection, or we could call it an array. We'll just call it an array. And then it'll take in a callback function. And then what it's going to do is it's going to take the last item from the array and then pass it into the callback function. So if we come down here. So I'm leaving this blank for right now. But let's come down here and then let's invoke this. So if we did last, so we're calling it. Now let's pass in our array, 1, 2, 3, 4, 5. And then we'll pass in a callback function like this. And so then the callback function is going to receive the last item. And then in here. All right, console.log last item. Okay, all right, so kind of working backwards a little bit, but this is how we're expecting to be able to use it. So last item. All right, so last item is then going to be the result of what gets computed in here. So then all we're going to do is we're going to go callback, array, and we'll say array.length -1, and that will always give us the last item in the array. So if we then come in and run this, we're going to see this 5 printed out in the console. Put in some other values. It's always going to print out the last item. And so I'm going to take that off there. Okay, so it's going to print out some things like that. So the callback function idea, so this is being used with synchronous code. The code that's going it's line by line. There's nothing kind of crazy going on, and so this is perhaps seems like a little bit of overkill to accomplish something simple like this. So here's when it becomes really useful. So if we look at what's it called? Sorry, I'm blank for a second. What's the underscore? There we go. Okay, so underscore, this is a library that you can pull into your code, and it has a lot of very common types of tasks that you would want to execute. And then it generally follows this, this callback type of a pattern. So for example, they have this function each in here, which each is a very, very common type of a function that's used in many different languages. And then the idea is that you pass it in a collection, and then you pass in another function, and then that function is going to be handling the result. So with each, the function that you're passing in is going to be invoked on each item that is inside of the array in turn. So starting from the beginning, getting passed in one at a time into the function that's the callback function. So it's nice because we can import this one underscore library, and then it has a whole bunch of different methods on it that allow us to handle a bunch of different very, very common types of patterns that we're going to come up encounter in our code. So here's like reduce, for example. Reduce is in here. So doing the same thing where we give it a collection, we have our function. Instead of accumulator, they call it memo. You'll see it written both ways. But again, just doing the exact same thing. So they do it with 1, 2, 3, they get a 6-pack. That's exactly what we used in our example before. A map. So a really, really good exercise for you guys would be to come in here and try to recreate all of these functions. This would be a fantastic exercise that would help you to really deepen your understanding of JavaScript and functions in general, and how all of those different things behave. All right, so okay, so this is the idea of a callback function. So when you get into jQuery, if you were to get into Axios, or if you get into any of those other different libraries that handle asynchronous requests, then callback function takes on a little bit of a different meaning from a high level, but and this is something that we go very in depth with in our course. But the idea is that this callback function is it's the point where the program is going to revisit this code at a later point in time. Because then it's if some type of action that's and again, I'm going a little deep here, but just if something happened like making an HTTP request to the server, or if you're waiting for user input, like a click event or something like that, for the user to click on a box or something like that, then you'll have these callback functions that are set aside, which will be invoked when those specific events occur. So again, yeah, so it may seem a little verbose at the moment, but that's just because we're playing around with little trivial implementations like this. When you get into like a larger code base, or you're starting to deal with asynchronous code, then this pattern becomes it becomes more apparent why this type of a pattern is useful, and why this type of a pattern would actually save you lines of code. So, but for what we're doing right now, and for the scope of this class and the scope of this lecture, anyway, this is a nice little introduction into callback functions and their basics. Okay. All right. There's one other advanced, a little more advanced JavaScript concept that I want to visit. And again, there's a lot of stuff that we have not covered in this mini bootcamp, that relates to JavaScript. I mean, we haven't really gone over the this keyword very much. I mean, we haven't gone over, constructors and stuff like that, a little bit, but we haven't really, like hoisting, we touched on that a little bit, but there's a lot of, even all the ES6 stuff as well, and, different features and types of iterations of recursion. There's quite a bit more information that that we haven't really touched on. So this is a good little introduction into the basics, but there's a lot of additional stuff that we can point you to if you want to continue your self-study. The JavaScript bootcamp that we did before goes a little more in depth into some of those other concepts like recursion, closure, callback functions, things like that. And so I would definitely encourage you guys to go and check out the JS mini bootcamp if you haven't, because that one goes a little more in depth with a lot of this stuff. So All right, so I'm going to touch on closures. This relates to callbacks. So with callback function is you're passing a function into another function, and then the idea of closure is that you have a function that, let me back up a step. So we have callback functions, which is where you pass a function into another function, and then we have higher order functions, which are functions that return functions. So let's say you have function foo, and it's going to return an anonymous function like this. Okay, so then we go var bar is equal to foo, like this, and then bar itself is a function. So if we do console.log, hi, like that, and I'll walk you through this in a moment, but we see that hi is printed out. So foo is a function, and then this function, when we invoke it, it returns an anonymous function. So foo right here, when we do foo, open parenthesis, close parenthesis, when we invoke this, it's going to invoke this larger function. It's going to, it will evaluate, this right here, this expression will evaluate to whatever is returned from the function foo. So the function foo is going to return this anonymous function. Again, an anonymous function is one that does not have a name on it. So it returns this anonymous function, and it assigns it to the variable bar. So bar is now a variable that we can use to reference this anonymous function, and then bar, we can invoke it just like that. So this is kind of like saying var bar is equal to this function, like that. So it's kind of like saying that. So it's essentially assigning a variable to whatever is returned from this other function. So there's a lot of different patterns that can result from this, and this allows us to, we can do things like creating private variables. We can do things to kind of decorate other functions. We can do things to, it's a lot of like the functional design principles tend to stem and emanate out from this principle right here. So there's a lot of flexibility that we have with functions in JavaScript and what we can do with them. There's a lot of powerful design patterns that emerge from that flexibility. And when you get into React code, that same type of a design is used all the time with higher order React components. Higher order functions are used all the time in Node when you're tying together your different files and modules and things like that in your backend code. So it's anyway, powerful design principle that shows up in a lot of places. So again, we go deeper into this idea inside of our JavaScript mini bootcamp lesson 4. So if you're curious into looking deeper into this, I would encourage you to go check that out as well. So all right, so this function returns a function that we assign a bar that we then invoke. Okay. So again, this is me kind of walking you through trying to help you understand the sequences or the way that the language behaves. So as this program is running, this function foo is defined, and then we come down to line 7, and then we invoke foo. Foo, we invoke it, and then this anonymous function is returned, and then this right here stays in that spot. So bar right now obviously would break because there is no bar variable, but we can do something interesting. We can write just open and close parentheses like this. So this again is a kind of a weird little pattern. It looks funny. We see the two sets of open and close parentheses, but if we run it, we see that it still behaves the same way. So what's happening here is that we call foo, so we reference foo. So again, foo references this function, we invoke it, and then this part right here is going to evaluate to whatever is returned from here. So what happens is this function gets returned. And then this right here will now be that anonymous function, and then we're immediately invoking it. We're calling it again right on the spot. So again, this is, if you're looking on Stack Overflow, you might see this type of code. You might see these types of things being written on there. That's what they mean. If you see this out in the wild, it means that this function returned a function, and then we immediately called it. So again, this pertains to that idea that functions can return functions, functions can receive functions as arguments. This function up here, it can reference stuff out in its parent scope. So if I did var message is equal to hi like that, and I did console.log message, then as we run this, we see hi is still printed out. So the function, it remembers its outer scope. Even though it's being evaluated right here, it still remembers this scope right here. And so if I did var message is equal to sup, if you think about that for a second, is it going to print out sup or is it going to print out hi? So kind of think about that for a moment. So foo, it evaluates, returns that anonymous function. We invoke it, and it's going to return hi. So again, this is the idea. This is called closure. This idea of closure. It's that when a higher order function returns a function, the function that was returned retains access to its original scope where it was written. So again, I'm going pretty fast over this. I'm just trying to kind of dump on you guys a bunch of topics, and you can rewatch this video. Going a little quick just because there's obviously so many things we could try to cover. But yeah, this is a higher order function and then this is its closure scope right here. These get asked about in JavaScript interviews all the time. And again, these are just some of the key JavaScript concepts that we expect our students to know and be familiar with at the start of the course, and then we just we run with it, starting from this base point. So, all right, so higher order functions, turning anonymous functions. Okay, all right, so this is kind of the next step. All right. Okay, let's look at, does JS have something similar to Python's decorators? Let's see. So I guess so I'm not super familiar with Python, but I guess the idea of a Python that it changes the, dynamically changing the behavior of a function, I guess. Having it directly, subclasses have changed the source code of the function being decorated. Yeah, I'd have to look into it a little bit more. I'm not the best at Python right off the top of my head. But yeah, I'll have to look into that. So what happened to the second hi from foo? So there's only so we only have one hi that's being printed out. Oh, if there were other ones being out down here, I clicked clear console to remove them, but it's only one console.log is being run in this code. So, and in effect too, right here in this example, does var message equals sup or get sup? This right here is it doesn't it doesn't affect any of the code. So that was just kind of an exercise showing that it's going to look at this message before it looks at the other one. Okay, all right. So yeah, there's some other functional patterns. Here's something else I want to talk about. I'd like to talk about scope. So function foo, function bar, function baz, like that. Okay, so you have a bunch of different functions all nested inside of each other. So, and then, let's see, baz will invoke right here, bar will invoke right there, and then foo will invoke right there. Okay, so they're all just going to be immediately called, right after we've defined them. So, if I put something in this top level function, if I say var top level var is equal to hello. Oops. All right. Then what happens is if we did top level var like this, all right. so if we run this right here, then it's obviously going to be able to print out hello. So, so top level var. So this is of course something that you're used to. So this function, we can of course reference all the variables that are inside of this function. If we were to look out at bar, if we were to take this variable definition and put it out here, and then run that again, we would see that it still works. If I were to cut this out, put this down here, see that it still works. I go up to here, it's of course going to still work. So the idea is that from within a function like this function, it can reach out and see everything in the functions that it is contained within. If it is a sibling function, so if I move this function into bar, and then clear that, run this, then we see that it all prints out. If I were to let's see, put this as a sibling function, and this is throwing off my indentation, so let me get that fixed so that makes it a little easier to read. Okay, all right, so right now we have bar, and then we have bar and its invocation right there, and then we have baz and its invocation right here. They're on the same level with each other. If I move bar down here, okay, so the functions are right next to each other. So this right now is going to print out, so we're going to see an error because top level var is not defined. And so what's happening is that so we cannot see into siblings, so sibling functions. Functions on the same level cannot see into each other. And then likewise, if I remove this console log and if I put this out here, down on the bottom, let me put it right here, then we run this, again we're still going to see that same error because it cannot see into functions that are above it. So again, scope, the innermost functions can see all the way out forever, all the way out to the global scope, but then functions can't see into sibling functions, and they can't see into functions that are inside of themselves, and so they cannot reference variables that way. So there's an ability to see out and reference other variables. It only goes one direction. It does not go both ways. So again, just a general concept. This is pretty much similar across many other similar across a lot of different programming languages. So anyway, yeah, just an important thing to understand about scope. Cool. All right. Nope, don't get it. Foo will return high. Foo will return high. Okay, so foo does not return high in that previous example. It returns a function in its unrun state. So if I were to pull that up again real quick, so let's say function foo, and then this is going to return an anonymous function like that. So if I go foo like this, and I'll walk you through this again in a moment, a little bit slower. So what's happening is that foo right here, this returns the anonymous function. I should have a semicolon there. So it returns this function in its unrun state, its pre-run state. So if you could think of functions as having like two different states, one is their pre-run version that has all of their code and their logic spelled out, and then the second one is after they've been run, and then they return or boil down to a single value that they return. Then this right here, so foo, in its pre-run state is this big function, but then once you run it, it's going to return a single value, and what it returns is this function. So this right here is going to be this whole function block right there. And then, so it returns this unrun function, which that function goes right here, and then we're immediately calling that function. And so this right here is going to be the result of calling this anonymous function in here. So that's, yeah, so this is kind of tricky, but the reason I wanted to teach this is because this really drills down and forces you to understand these kind of the fundamentals of how functions and expressions work within JavaScript. And so yeah, this is like kind of tricky, and let me post this example code in Slack. But this I felt like this code right here hopefully is going to break some maybe like incorrect notions that some of you might have about how the language behaves. And so anyway, it's funny how it indented that. But yeah, so what it's doing, so the other alternate way to do it would be so the example that I had before would be if I did var bar like this, and then I invoked bar. So those are doing the exact same thing. So this right here will call out hi, and will behave in the same way. But then if I nuke that, just put the parentheses right after it, it's going to do the same thing. So yeah, okay, so yeah, general practices with using JavaScript. So when you're writing your code, be consistent. So if you're going to use semicolons, or if you're not going to use semicolons, like be consistent. So some people now with JavaScript they don't use them, but just like be consistent with your code. If you're writing function declarations like this, just use function declarations. Don't switch in the middle and then start throwing in function expressions like this, like defining them differently. So just that's like one of the biggest things that we see just with like new developers is just being consistent, keeping your spacing consistent, keeping your indentation consistent. Yeah. Oh yeah. So if you just call foo, and let me I'm gonna console log the result of calling foo. So if we run that, we see it's a function. So that's what foo returns. Foo returns a function. So it's literally a function. It gives you 3 lines of code, and then we can call that code to then get the result of it. So yep, yeah. So there we go. So yeah, good question. So hopefully that helps. All right. Let me. I feel like I might have missed a couple. Variable. So yeah. So anyway, this is kind of a so higher order functions. Anyway, kind of funny syntax, but yep. All right. So there you go. Yeah. Let me know if you have any other questions. I'll take a look in the Slack channel. But yeah. All right. Well, thanks, guys. Thanks for attending this class. I'm glad you were able to come in and hopefully learn some good web development skills, and got at least a little bit of an introduction into some JavaScript and HTML, stuff like that. Yeah, check out our other courses. Oh, I do a recursion example. Yeah, I'll do it real quick, and then I gotta hop off. But let's do a let's do a quick one. So recursion, you can kind of think of it as like snake eating its tail, or this fits in really well. It's so functions can be passed in as arguments into other functions. Functions can return functions, and then now with recursion, a function can call itself from inside of itself. So if you have a function like this, the function can call itself from within inside itself. So this right here will actually crash my browser, depending on the way JSFiddle handles it. But because what's happening is that I call foo, and then foo is going to call foo, and then that foo is going to call foo, and then that foo is going to call foo, and it's going to go on forever and ever and ever. So so it's going to create a so it's going to create what's called an infinite loop. So and it will go until your computer crashes or dies. So. All right, so that's just the general basic idea. So usually what's happening is you're passing some value down, and then you'll have some kind of base case that will cause you to terminate your recursion. So, but again, there's different styles of recursion, different ways that you can use it. It's common to use it with searching and sorting algorithms. You'd use it all the time with data structures when we get into linked lists and things like that. Recursive solutions. So it's iteration with a function. So anything that you can write with a function or a recursive function can be written with a while loop. So a while loop would be the easiest way to duplicate the behavior. While loops and iteration are general iteration are generally more efficient. When you get into recursion, you have this idea of adding a whole bunch of frames to your call stack, and it can be a little more of an expensive process. And so recursion, funnily enough, like when you're first learning it, you're like, when would recursion ever be more simple than a for loop? Well, when you get into some really complex solutions, and once you're trained with it, recursion will actually be a little more simple to understand than a basic like a for loop or a basic while loop. There's tasks where it is easier to do it with recursion. So again, like examples, because I know I'm just speaking in general terms, but a good example for this would be like if you're searching a tree or a graph data structure, or if you're searching a linked list, it's often a lot easier to write those solutions recursively than it is to write them iteratively. And so again, when I say iteratively, that means a for loop and a while loop. And so again, it's when you're getting into a little deeper CS stuff, getting into data structures and algorithms, that's when recursive solutions become a little more useful. But again, just the basic idea is that you have this function on the inside, it's calling a function on the outside. So go and check out our JavaScript mini bootcamp lesson 4. I cover a lot of this stuff, and I cover recursion and even more, a little more in depth. And and go over some basic examples. But I guess, well, let's actually, let me just check real quick, check if there's any questions. How about this? Let me do a factorial. So just as a quick example. So this is one of the classic recursion examples, like factorial, or the other one is a Fibonacci. Those are the two, like every textbook out there that teaches recursion are probably going to have these, are probably going to have these as like their first examples. So anyway, you'll see these pretty simple. But so yeah, so what we'll do is we're going to take in a number. So, and again, a factorial of a number is of an integer is that integer multiplied with every integer less than it. So a factorial of 5 is essentially 5 times 4 times 3 times 2 times 1. So it's 120. So that's what the factorial of 5 is. And so what we're going to do is we're going to say if n equals 1, return 1. Actually, let's do if n is less than or equal to 1. Okay, because it goes to 0. All right. So this is our base case. So if we don't have this, then the factorial function is just going to continue looping forever, and we're never going to hit the end. But then otherwise, we're going to say return, and we'll say n times factorial of n minus 1, like that. Now let's do factorial of 5. Let's log it out. All right, so let's run this, and oops, let's see, how did I do? So n times factorial of n minus 1, and then let's see, I might clear this out. Okay, all right, debugging. So let me walk you guys through how to debug this. So, all right, so generally there's a statement we can use called the debugger statement that you can throw in, and then that helps you, oh, I'm sorry, this should be less than or equal to 1. That's why it's returning 1. So I spotted it right off the bat. But ways that you would debug this is you could throw a console.log in and start logging out values. There's also a debugger statement that you can put in Chrome. This will pause execution where it hits, and you can go and walk through and examine the values as you're going through. But yeah, there's another thing too that you can use. There's another thing that you can use as well that's called a let's see, Python tutor. So you can go to pythontutor.com and it gives you a way to visualize your code. So let me actually go on and print that in there. Yep. So that allows you to visualize how you walk through it. So, but anyway, if I run that, that gives us 120. So yeah, so just we call the same function, but then we modify the value that we're passing in. So again, the keys are that you need to have a base case that terminates the recursive execution, and then you need to be gradually moving towards that base case. So right here, my base case is if n is less than or equal to 1, and then the other case is if, or the other aspect is that I am decrementing n. N is getting smaller and smaller, so n is gradually moving towards this base case. And so that's how I know that this will not get into an infinite loop. So anyway, something to think about. So all right, so there you go. Kind of fast, but there's a basic example. You could go see if you could do, you go try to do that with like Fibonacci, try to do the Fibonacci sequence. I generate a couple numbers, like don't go forever with it because it'll crash your homework. But all right, so here's your homework, and so this relates to the callback idea. So there's that homework as well. So thanks, Jason. I'm glad that you liked it. So yeah, again, just kind of a basic intro. And this last lesson was me just kind of jumping all over the place, touching on a bunch of different advanced concepts that relate to functions specifically, just generally because these are the things that trip up newer people when they're learning. And so hopefully this gives you a good resource that you can use to help jumpstart your understanding with these different concepts. So yeah, definitely get better at recursion. Recursion is something that gets asked about a lot. Find a good data structures and algorithms course online. That's like 90% of what 90% of what like interviewers ask is just stuff about data structures and algorithms. It's usually like the second, like first or second class that's taught in a computer science program. So great. All right. Well, thanks guys. Thanks. I appreciate it. So thanks for the compliments. Glad you guys could be here. So yeah. Anyway, this stuff will all be up online and available for you guys, and happy to have you guys all stick around here in Slack. And yeah. If you have any other questions about future courses that we have, whether a part-time course or full-time course or a 6-month-long class, just let us know. And then yeah, our hope is to we have several other full-time teachers that we're looking on bringing on, and then that will give us the capacity and the ability to be able to scale out and have multiple concurrent classes running at the same time, so we can better service more people. So anyway, yeah, thanks everyone. Take care. Have a good night.